Okay, so in section 3, we're going to talk about chords specifically and how to use them in a circle, if it's a diameter, if it's not a diameter, all the things that we can do with chords. We have a few theorems to start with. Theorem 6 is the congruent corresponding chords theorem, which says in the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. So if we know that AB is congruent to CD, then we know that those chords, or the chords are congruent, so we know that those arcs are congruent. So we know that arc AB and arc CD have to also be congruent. Theorem 7 is your perpendicular chord bisector theorem, which says if a diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So we have our diameter EG, we have our chord FD. They're perpendicular at point H, which means FH and DH are congruent, but also FG and DG are congruent. And then the last theorem is the perpendicular chord bisector converse. So if one chord of a circle is a perpendicular bisector of another chord, then the first chord is the diameter. So if we know that PR and PT are congruent, and we know that it forms a right angle, then we know that SQ has to be the diameter of that circle. Okay, so in 1 and 2, we're going to use the same picture off to the right. So if the measure of arc AB is 110 degrees, we want to find the measure of arc BC. Well, AB is 9 and BC is 9. So since they're congruent to each other, those two arcs have to be congruent. So the measure of arc BC has to be the same thing as the measure of arc AB at 110 degrees. Now, when we look at number 2, we're going to forget everything we did in number 1 because they are not connected to each other. It's just the same picture. If the measure of arc AC is 150 degrees, so that's going to be this arc down here. If that's 150 degrees, we want to find the measure of arc AB. Well, the chords are still congruent, which means that the arcs are still congruent. So if this piece is 150 degrees and there's 360 total, that leaves us with 210 degrees between these two arcs. Well, they have to be the same. So the measure of arc AB has to be half of that 210 so that they're both the same, which is going to give us 105 degrees. So in 3 and 4, we're also using this same picture off to the right. So we want to find the length of CE first. So that's going to be this chord right here. Well, we know we have a diameter and we have a right angle, so it's going to bisect that. So if CF is 5, then FE is 5, which means CE is 5 plus 5, or 10. Now, when we look at the measure of arc CE, we have a little more work to do. We know that CD and DE are going to be congruent to each other from that theorem. So we know 9x is going to equal 80 minus x. So we add our x over and divide by 10, which is going to give us 8. So the measure of arc CD is going to be 9 times 8, which is 72 degrees. The measure of arc DE is going to be 80 minus 8, which is 72 degrees. And to get the measure of arc CE, we just have to add those two pieces together, which gives us a total of 144 degrees. The last theorem in this section is Theorem 9, the equidistant chords theorem, which says in the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So equidistant means they have to form a right angle. So if from the center of your circle to those chords don't form a right angle, you can't use this theorem. So, but when we know that, so if we know GE and EF are the same distance, then we know AB and CD are going to have the same length. Okay, so the key to problems like number 5 is to label everything you're given and go from there. So we're told that QR and ST are both equal to 16. CU is 2x. CV is 5x minus 9. They want us to find the radius of circle C. So we know that the two chords are the same, and we know that CU to CV are going to be the same because they're both forming right angles with chords that are congruent to each other. So 5x minus 9 equals 2x. I'm going to subtract my 5x to get negative 9 equals negative 3x. And when I divide my negative 3, I get x equals 3, which means that those are both going to equal 6. 2 times 3 is 6. 5 times 3 is 15. Minus 9 is 6. Now, we know that QR is 16. We know that WX goes through the center of the circle, so it's a diameter, and it cuts that chord at a 90-degree angle, which means it's going to bisect it. So if the whole thing is 16, then that means each of those are both 8. So here's the easiest way to solve that. I'm going to connect Q to my center to form a radius, because it's going from the center to a point on the circle. I now know the two legs of that right angle, that right triangle. So 8 squared plus 6 squared has to equal that radius squared. 8 squared is 64. 6 squared is 36. When I add those together, I get 100. The square root of 100 gives me a radius of 10. So it's just a matter of finding that length from the center to the chord and then forming your right triangle. If you can form your right triangle, it's just Pythagorean theorem to solve for that hypotenuse, which is your radius. In number 6, you're doing the same thing, so I'd encourage you to try it on your own, see how far you can get, if you can get it all worked out, to solve for that radius of circle N. So I know that the chords JK and LM are both equal to each other, and they're both 24. NP is 3x, NQ is 7x minus 12. So those both form right angles with that chord, so they're going to be equal to each other. So I'm going to subtract my 7x to get negative 4x equals negative 12. And I'm going to divide by negative 4 to get 3. So I know that that's going to give me 9 for both of those lengths. So since JK was 24, I've got a diameter that goes through it, so it's going to cut it in half. So it's going to make JP 12 and PK 12. And I'm going to form that right triangle to solve for my radius. So I've got a leg of 9, a leg of 12, equal to my radius squared. So 9 squared is 81. 12 squared is 144. When I add those two together, I get 225. and I take my square root to get r by itself to get a radius length of 15. So that is chords, using chords, solving for lengths and all of that. If you have questions, let me know, email me, get on Google Meet, whatever you need.